Today's our topic is comparative static analysis. Now in the comparative static analysis we are taking a model from the macroeconomics that is called complete Keynesian model, and we have derived some of the equilibrium conditions that we have derived from the complete Keynesian model. We are going to use those equilibrium conditions. So the first equilibrium condition that we are going to use is basically the product market equilibrium condition. Now, if you have a very basic knowledge about the complete Keynesian model from the macroeconomics, then you can easily say that the product market equilibrium occurs when the saving is equal to investment. And we all know that saving is basically a function of income and investment is a function of rate of interest. As our income increases, our saving also increases. So as y increases, saving increases. So it is a positive function of income. Saving is a positive function of income. Similarly, as our rate of interest increases, our investment decreases. So rate of interest and investment is a negative function of the rate of interest. We have given a shifting parameter to this equation, that is alpha and beta. So it has now become savings plus alpha is equal to investment plus beta. Alpha and beta are nothing but the shifting parameters. Alpha can be tax or anything else, and beta can be government expenditure. These are basically an example of alpha and beta. What are the things that alpha and beta can be? So next we are going that as I have said that as saving increases, so income as our income increases, so our saving will also increase. So this is a positive function. So the first order derivative of the s dash y is basically greater than 0 or positive. Similarly, I dash r is negative because as rate of interest increases, investment decreases. So it is a negative function of rate of interest. Now in the complete Keynesian model, the money market equilibrium condition is given us. I am not going to take this form of the money market equilibrium condition. I am going to show you the actual form of money market equilibrium condition which we are going to use in the determination. So the actual form of the money market equilibrium condition that we are going to use in the analysis, in the comparative static analysis, is basically this form. This is that money supply is basically KPY plus L2 of R. L2 of R is nothing but the speculative demand or speculative motive, the transaction that we do in the speculative motive. So this is the money market equilibrium condition. Next we are going to the production function. We know that the production function is basically the function of labor and capital. So here it is given as that y is equal to function of n and k0. Y is basically the output, and output is basically a function of labor, amount of labor used in the production, and amount of capital used in the production. So y is the function of n and k0. If we do the first order derivative of the labor, then that is f dash n, and f dash n is obviously positive, and similarly f double dash n is negative. So the first order derivative of the labor is positive and the second order derivative of the labor is negative. Now the labor demand function, basically the labor demand function, we know that that is basically W by P. What is W by P? W is the wage, P is the price level. So if we divide the wage by price level, then we are getting the marginal productivity of the labor, and marginal productivity of labor is basically f dash n. Okay, so we can write that if we put this P into this side, then W becomes P into f dash n. So this is the money wage rate. Okay, W is basically the money wage rate. Now labor supply function, this is the labor demand function which we derived, from which we have obtained that W is equal to P into f dash n. Similarly, if we go to the labor supply function, then that is W is equal to W bar plus W of n. W is money wage rate here. W bar is historically given wage rate, the wage rate that we take from any base year that is taken historically, and W of n means wage, that is a function of labor. So let me show you again that this is the value of W, that is P into f dash n. It is derived from the wage, it is derived from the labor demand function. W is equal to P into f dash n. It is derived from the labor demand function, and from the labor supply function we have derived that W is equal to W bar plus W of n. So we can equate these two forms of the, because this both of these are values of W, both of these are values of W. So we can equate these two forms. When you equate these two forms, then it becomes equilibrium for labor market as it is given here, that P into F dash N is equal to W bar plus W of N. So this is our fourth equation. Now let me revise all of those three equations that we have derived from the entire theory. The first equation is basically sorry, but this is given as the second equation, but this is supposed to be the first equation. Let me correct it here. This is the first equation, this is given as second, but it is not second, it is the first equation. Similarly, now this is given as the third equation, but this is not third, this is basically the second equation. Which one was our first equation? Our first equation was this equation. So our first equation is basically this equation which we have obtained from the product market equilibrium condition. So this is our first equation. The product market equilibrium condition is obtained or shown by this equation. Now our second equation is basically from this function, that is the money market equilibrium condition. This is our second equation, and we have also obtained the third equation, which is this production function y is equal to function of n and k0. Basically output is a function of labor and capital. So it is our third equation properly shown here, and our fourth equation, that is the equilibrium of labor market. So product market, money market, and production function, and equilibrium of labor market, these are our four equations that we have obtained. Now here y, n, r and p. What is y here? Y is output. What is n here? N is basically amount of labor. What is r here? R is the rate of interest, and p is the price level. So these four are the variables that we have to find out. Now we have to differentiate the equation 1, equation 2, equation 3 and equation 4 with respect to M. That is our total money supply. So M is our total money supply, which we have put in the in this equation where the money market equilibrium was shown. This was basically M. M is the total money supply, and this entire part KPY plus L2 of R is the total money demand. So money supply and money demand equates, we get the money market equilibrium. Now this M, we will differentiate equation 1, equation 2, equation 3, equation 4 with respect to this total money supply or M. So this will be our base. We will try to differentiate all the four equations with respect to the M. Now, so at first we will start with the first equation. This is our first equation, and we will try to differentiate this equation with respect to M. So S is a function of y. We will have to apply the chain rule here. So S is a function of y. So at first we have to do the derivative of the S with respect to y. Then we will do the derivative of y with respect to M. Similarly in this part, and alpha is basically a parameter, so it will be converted into 0 when we will do derivative of the alpha with respect to M. Similarly in this part, I is a function of rate of interest or R, so we will do the derivative of I with respect to R, then we will do the derivative of R with respect to M, and beta will be converted into 0. This del S, del Y is written as S dash Y, and this I, del I, del R is written as I dash R. We are taking all those terms on the left hand side, and we have obtained this equation. This is obtained from the first equation, that is the product market equilibrium condition, and we have obtained this from that equation by doing the differentiation with respect to M, or the total money supply. Similarly, if we do the differentiation of equation 2 with respect to the total money supply, we get this. So here M will be converted into 1, del M will become 1, Kp, and this y will have the derivative. K and p are the constant parts, so it will be taken outside, and we will have the derivative of y only, that is dy dm. And L2 is a function of R, so we will have to apply chain rule again here. As L2 is the function of R, so we will do the derivative of L2 with respect to R, then we will do the derivative of R with respect to M. So this is basically applying chain rule, and we can write this entire term is equal to 1 because del M has become as 1. Now we will do the derivative of the third equation. We will do the derivative of the third equation with respect to m. So when we are doing the derivative of the third equation with respect to m, then that is dy dm equals to, as we have written that f of what was the third equation? Our third equation was saying that y is equal to function of n and k0 or n on k. You can write n and k. So basically k is a capital and n is the amount of labor. Now capital is constant, we are taking capital as constant, so this part will not be taken, and this part will become obviously 0 when we will do the partial derivative of this part. Now so we have to do the derivative of n only. So when we are doing the derivative of n, that is basically the amount of labor. So now it is a function of labor, so we have to do the derivative of the function with respect to n. Then we will do the derivative of n with respect to m, that is our total money supply. So then we will do the derivative of n with respect to m. So as I have shown here also, in the fourth part we will do the derivative of the last equilibrium condition, that is our labor market equilibrium condition. So in the labor market equilibrium condition, if we do the derivative, then we obtain this form. We will write it as this form. We will take the dn dm. dn is here also and dn dm is also here, so we will take common of dn dm, and this part minus this part, that is del w del n has become minus w dash n, and when it is coming to the left hand side, it has become w dash n. So this is basically the entire derivative of the four equations that we have obtained from the four market equilibrium conditions: producers market equilibrium condition, goods market money market equilibrium condition, and the production function, and labor market equilibrium condition. So now we have to just plot from 5, 6, 7 and 8, which was basically our 5. When we have derived when we have obtained, look wait, no, 5, 6, 7 and 8 are not here. So when we are doing the derivative of the product market equilibrium condition with respect to m, this has become, or this has been obtained by us. So this is basically our 5, equation 5. Similarly, when we are doing the derivative of the money market equilibrium condition, what we have obtained is basically the number 6 equation. Similarly, when we are doing the derivative of the third equation, that is our production function, then we are obtaining equation 7, and lastly we are obtaining equation 8 when we are doing the derivative of the labor market equilibrium condition with respect to the total money supply, or m. Now from 5, 6 and 7 and 8 we will form a matrix. Now let us try to find dy dm. How will you find dy dm, and is it possible to find anything else? So by this method actually you can find dn dm, these four variables. You can find dy dm, that we are going to find in this portion of the video. Similarly, you can find dn dm also, you can find dr dm, and you can find dp dm also. All of these four you can find. Now how to find these values, dy dm or dn dm or dp dm or dr dm? We are just going to find out the values of dy dm here. Now as you can see, I have formed a matrix. Let me tell about the denominator at first. How have I formed the denominator? What is the process of forming the denominator matrix? Now the denominator matrix is very simple. It doesn't even matter whether you are trying to find out dy dm or dr dm or dp dm or dy dm dr dm, anything, dy dm dr dm dp dm, the denominator part will be same. So how to form this denominator matrix? Now at first I will explain the first row of the matrix. Now If you go to the product market equilibrium condition, this is very easy. Just focus a little bit, focus, you can easily understand it. Let me clean the board at first. So as you can see here, this is our product market equilibrium condition, and we have when we have done the derivative of the product market equilibrium condition with respect to M, that is our total money supply, then this is the equation that we have obtained, right? So in this equation basically in this equation, what is the coefficient of dydm? What is the coefficient of drdm? The coefficient of dydm is s dash y, and the coefficient of drdm is minus I dash r, right? So remember these two terms, s dash y and minus I dash r. As you can see here, that those two coefficient has been put here, s dash y and minus I dash r. Why are these two terms 0? Because there are 4 variables. So dydm except dydm drdm, we also have dpdm, and dndm. Now dpdm and dndm are not in this equation, so we are taking that dpdm and dndm are in this equation as 0 into dpdm plus 0 into dndm. So it is 0 into anything is multiplied by 0, anything is, it is becoming 0. So the coefficient of dpdm and dndm for the first product market equilibrium condition is basically 0. So that's why we are putting 0 in other two parts. Similarly, from the second equation, that is the money market equilibrium condition, we will also try to obtain the values of the coefficient, but you have to maintain the order. Now here s dash y is basically the coefficient of dydm, right? If I am telling it right, look at this. S dash y is basically the coefficient of dydm, and I dash minus I dash r is drdm, the coefficient of drdm. So in the next equation, dydm has the coefficient kp and drdm has the coefficient L2 dash r. Just put it here. dydm has the coefficient of kp and drdm has the coefficient of L2 dash r. Other two, that means the drdm and dpdm, are not in the equation, so it is 0 0. In the next equation when we will go, that is the production function. So when we have done the production function derivative, then we have obtained this. Now as you can see in this equation we only have the value of d and dm, right? So when we only have the value of d and dm, that means we only have the coefficient of d and dm, and we also have the coefficient of dydm, because the coefficient of dydm is supposed to be 1. But what about dpdm and drdm? Now those two are considered to be 0. So similarly, the coefficient of dydm is 1, so we have put it 1 here. Coefficient of drdm is 0, so we have put 0 here. Coefficient of dndm is del f by del n, so we will put del f by del n here. Now del f by del n can be written as f dash n, and as in the equation, if we convert it in the left hand side, take it in the left hand side, it will become minus f dash n, so it is written as minus, sorry, I am pointing it in the wrong direction, it is minus f dash n here. Now similarly, in the last equation we have obtained we have just put the coefficients and how to form the numerator matrix. Now that is the concept, how to form the numerator matrix. Now the numerator matrix is very easy. We have to just be cautious about what you are actually trying to find. If you are finding dydm, as I am finding here, I am trying to find dydm here. So just look at the matrix, just look at the denominator at first. So if you look into the denominator, all the other things are same. 0, 0, 0, 0, and this all parts, this second and third row, so sorry, second, third and fourth column are completely same. And as well as the second column, that is also same. But the first column is different. Right? The first column is different. And we also say that why is this difference being arising in the numerator matrix. Now as we have put the dydm, the coefficient of dydm in the first part in the denominator, so in the numerator matrix we are actually plotting the coefficient of dydm in the first part also, but as we are determining dydm, so in the first column we will not put the coefficient of dydm, we will put anything else. Now why have I chosen the first column? That is a very important question that we have to understand. Because the value of dydm was in the first place. First place, that's why I have chosen the first column. If we are trying to determine drdm, then the value of drdm is supposed to be in the second column in this position. Then I have chosen the second column. I hope you guys have understood it. Now how to plot this value of this first column? That is a very simple thing. You have to just take the equations. Here the equations are written here, and we have to take the right hand side part of the equations, that is 0, 1, 0, 0. Just plot these values in the numerator part, 0, 1, 0, 0. After solving this matrix you will get the value of dydm. That means due to 1 unit change in money supply, how will our income be affected, or how will our output be affected? Due to 1 unit change in money supply, how will our output be affected? That is dm dy. Due to 1 unit change in m, how will our output be affected? So that is the value, and obviously this value has been obtained minus I dash r into f dash square n minus s dash of y into L2 dash of r into f12 of n minus f dash square of n minus I dash r into kp into f dash square of n. Now as we know that L2 dash r is negative, because as rate of interest increases our precautionary demand, our speculative demand for money decreases. We know that because when our rate of interest increases, our speculative demand for money decreases. Okay, so that's why it is negative, and I dash r is also negative, because as rate of interest increases our investment decreases. So numerator, denominator both are positive. How? Because I dash r is negative, so negative is being cut out at positive, and f dash square is of n is always always possible, it is positive, so numerator is positive. Similarly denominator will also be positive, because L2 dash r is negative and minus s dash y is negative, so minus and minus will be multiplied as plus minus, and minus r dash r is also positive, so this has taken minus into the negative value, so it is also becoming positive. So this entire term will be taken as positive.